let's graph the solution to the following system of inequalities. Okay, so we have two inequalities here. Y is less than negative 3x minus 2, and then we have y is greater or equal to 2x minus 9. So the first inequality can't be equal. So the first note that I'm going to have is I'm actually going to put an asterisk on that inequality, and then we're going to realize that we need to graph the lines y equals negative 3x minus 2. And we also need to graph, I did say lines, so plural. We also need to graph this line, y equals 2x minus 9. However, the first inequality, it says y is less than. So when we have strictly less than, we're going to make sure we graph this line to be dotted. Okay. The second inequality, though, is greater than or equal to, and the emphasis is or equal to. So it will allow for equal, so we're going to shade the equal symbol in the end. So what happens is this is going to be a solid line. So the solid line here is going to indicate that we will actually shade that line altogether. Okay, let's graph these. Graph the first line, which is dotted. Okay, so we could use y equals mx plus b form, and so we have a y-intercept of negative 2, and the slope is negative 3. So let's put a negative 2 here, and let's count 3, 4, 5, and that's negative 5. And we need to go 1 unit to the right. So when we graph in y equals mx plus b form, we'll start with the y-intercept, and then we travel the slope. So down 3, right 1. And then we play connect the dots. But this time we're going to connect it with a dashed line or dotted line. Okay. We're going to graph the second line now. The second line is y equals 2x minus 9. So the y-intercept is 0, negative 9. So negative 6, negative 7, negative 8, negative 9. And so we want to plot a dot there. Now we're going to travel the slope. It's up 2, right 1. Plot another dot. This time you draw a straight line through there. I guess I could try to use the ruler. If you have a straight edge, it might be wise to use it. It'll make your graph that much nicer. And so especially if it's going to be a solid line anyway. So a straight edge would be preferable. It'll make your graph that much neater. Remember to put little arrows at the end. Okay. And now, because it's an inequality, we want to shade the true regions. Okay, and what is the true region? Well, we're going to need to figure out which way do we shade for the red dotted line. So we're going to test star, and we're going to test the original inequality, and what we're going to do is choose a test point. So the test point just doesn't have to be, well, make sure that the test point is not on the dotted line, okay? Just make sure the test point is not on the dotted line, because if it's a dotted line, we can't shade that test point anyway. So you can see that 0, 0 is not on that dotted line, okay? So when we test star, that means we have 0 is now less than negative 3x minus 2. Oh, sorry, I take that back. 0 is less than negative 3. Come on, 3. I want my 3. 3, there we go. 0, okay. Little eraser there. And then we have a subtract 2. What does that mean? 0 is less than negative 2? Really? I don't think so. So we say it's false. And that means we do not shade 0, 0. Okay? We do not shade 0, 0. We do not shade 0, 0 because we have a false inequality. In fact, we're going to shade away from 0, 0. If you pick a test point on this left side of that red dotted line, you're going to realize, oh, that's where we want to shade anyway. So I'm not going to shade the entire thing. I'm just going to draw little arrows indicating we're going to shade to the left of that red line. Okay. Let's test double star there. Let's test double star. So make sure, once again, for the second inequality, don't pick a test point that actually lies on the line. Okay. Yeah, even though the line is already shaded, we still don't want to pick a test point that lies on the line because it could result in a lot of errors. So what's not on that solid blue line? Once again, we could pick on a nice convenient point. A nice convenient point would be 0, 0 as well. Now you don't have to. You could pick, 99, 0. Okay, 99, 0 is not on that solid blue line. Okay, but for convenience here, just make sure your test point is not on the line. So now we have what? 0 is greater than or equal to 2 times 0 minus 9. True or false? This time, this is true. This actually says 0 is greater than or equal to negative 9. That is true. So what does that mean? This time we will shade 0, 0. And if we will shade 0, 0, that means 0, 0 is on the true side. Now, where do these arrows overlap? That's the key. Where the arrows overlap is where the actual true region is. True region. Let me say that again. True region. Okay, so when do these arrows collide or when do they overlap? Let's find out. I guess I could draw a crisscross region if you guys like to see. Well, there's blue here, right? We shade this way. And so there's actually blue here, if you look very carefully. But we only shade where they intersect. So when do the red lines and the blue lines intersect? They're going to be here. And so you get this nice crisscrossing pattern if you use color. If you use pencil, it doesn't really matter. Just make sure you actually get what we call the intersection. And so there you go. Where the red lines and blue lines are overlapping, that's where you're going to get your answer. Obviously, you could even put more shading in here. It really doesn't matter what color you use. Just make sure you realize this is where they overlap, where the shading overlaps. Ooh. So there you go. That's how we graph a system of inequalities by making sure you actually shade the true region.